Yo, what's going on, guys? Christian here. Um, I don't know, my audio was showing weird on the last video. It came out kind of weird, so I just restarted. Um, so I was explaining that they're giving us a 32-bit integer, but it doesn't want us to. It wants us to calculate the integer in reverse, but it doesn't want it to be outside of the 32-bit range. And I was explaining how overflow works, especially with signed. So signed values, if the say we have something like this. Sorry. This first bit is reserved for, if it's a 0, it'll be positive. If it's 1, it's going to be negative. So in the case that overflow occurs and it turns into this, it's a completely different number. So it doesn't want us to exceed that range, essentially, is what it's telling us. So assume the environment does not allow you to store a 64-bit integer, signed or unsigned. Okay. It's kind of specific. So like the first thing that comes to mind is reversing a string. I'm not sure if that's an acceptable way to do it, if it'll let us. So I guess I'll show it to you, and I'll show you a different way you can do it. So first things first, we'll just we'll convert it into a string. So we'll do I think it's like this. Let's convert that into a string, and then we can just reverse it, right? So then we'll do s num, and then Python, it's pretty easy to reverse stuff. You just go like that. So this this is like the incrementer. So if it's -1, it does it in reverse, essentially. So we'll get that. So if we look at some of our cases here, if we were to convert this to a string and literally reverse it, this minus sign would end up at the end of the problem. And that's not what we want. So something pretty simple we can do is, since we didn't change anything with x, we can still check x. So if x is less than 0, then it's going to be negative, right? So in that case, that means this negative is at the back. So what we can do is we can reinitialize s reverse to this. So we'll do so first we add the minus to the front, and then we'll get the rest of this string. So it'll be from, let's see how I'm going to do this. So it's already in reverse. So we'll get it from the front to the length of the current string, right? And then minus, not -1, because that would just be, yeah, -1 actually. So like that. So in that case, it would grab, so in the case of the original number being -123, in reverse it would be this, right? It'd be negative, 321, and then minus, right? So what we're doing here is we're adding a negative to the front, and then we're just grabbing these values here and excluding this last value. So it'll be what we want, right? 321. That's only if x is less than 0, which is perfect. So then now that we have that, we got to check to make sure this number, well, I guess we got to convert it back to an int, right? So then we do int of whatever this is, and then we can do a check if, so this is the range it wants us to look at. So it's 2 exponentially to the 31st is less than x, right? So less than x, because it's -1, so this should be fine. And negative times 2 to 31st, right? Yeah, that should be right. And x is greater than or equal to this. So it'll be, no, it wants to be in that range. So if x is greater than that, right? No, wait. Yeah, that's perfect actually. Wait, no, sorry. It's supposed to be less than. And then in this case we'll return 0 instead because it's outside of the range. And then if not, we'll return as integer. So let's see if that works. Didn't really check anything. So it did work. Okay, cool. So let's see, add these test cases, run code, make sure we're getting that 0 when we're supposed to. Okay, srev, something's wrong here. S is not defined. My bad. Okay, so that's good. So that means we're actually getting into this loop when we're looking at that negative number. So all the test cases worked. Okay, so we can try submitting. So something I'm thinking about right now, it might accept it. Output expected 0. So my range is incorrect for some reason. So we're giving it the right answer, but this is not good. Let's see. So they look like they're positioned correctly. So the range is -2 to the 31st. So this is less than or equal to x, right? So I'm putting x is less than that, then that's bad, correct? So in terms of the greater than, so it's -1. So I think that should be okay. So I'm supposed to get 0, but I'm not getting 0. Oh, because I'm comparing it to x. This would be s int, right? Because then I'm just comparing it to the OG number, so it's going to keep giving me that result. I keep accidentally, oops. Oh, I thought I opened something. So I'm still getting it wrong. It's not good. Let's see. So is there something wrong with my range? No, it looks okay actually. This x is greater than that. So I'm supposed to get 0. So what is 2 to the 31st actually? So go 2 to the 31st, right? So this is the number. It's 3, 6, 9, 10. 10 digits. So this is larger than that, right? 3, 6, 9, 10. Yeah, it's bigger than that. Oh, it's or. My bad. That's why. Okay. So this should work. Something I'm thinking about right now, it was accepted, but the way I solved it is not within the constraints, right? Because of the fact that I actually store this integer in here. This is over a 32-bit integer, which is, is one of the main constraints here. It's like assume you're not allowed to store 64-bit integers, and it's not even allowed to go over 32 bits at all. So this solution isn't going to work. Technically, like, it works, it was accepted, but it's not correct. So what we can do is, there's a different solution. So we can solve it by not converting it into a string, but by checking it index by index. It's gonna be a little weird, so just bear with me for a second. So we have x, and then we'll set reverse value to 0. That's where we're going to be storing everything into. So while x doesn't equal 0, because we're going to be dividing x by 10 to take each index, starting from the ones place and going all the way to the bigger values in the number, and we're going to be adding it into here. So let me think about this for a second. So reverse should be equal to So each time we add a number, the next time we go through the loop, that number goes into the 10th place, right? So I'll give you an example. So we have 1, 2, 3, right? So first thing we're going to do is we're going to look at this value, right? So we want to do x percent 10. So this is a modulus. So essentially what that does is it divides this number by 10. So technically that'd be, the answer would be 12.3, right? But instead of giving you that number, this modulus, it just gives you the remainder, right? So it literally does 12. It literally does 1, 2, 3 divided by 10, and then it clips off this remainder, and that's what this is. So x modulus 10 for this is going to be 3. So that's going to be in the ones place. We have to take into consideration, like, what if we're actually here, right? What if we already have the 3 place stored in reverse? And we're on the next iteration, we're looking at 2. So what are we supposed to do with this 10? Well, since we're reversing it, right, this 3 is supposed to be in the biggest place. So by doing that, we understand that the previous value of reverse, we're going to multiply that times 10. And then we're going to add this x onto it, right? So let's kind of trace this. So say reverse equals to the number 3, right? So we want the final value to be 3, 2, 1, right? So we're going into this loop and we're looking at this value 2. So looking at this value 2, I guess this might be confusing because the way we're going to look at this value 2 is we're going to do this. We're going to be dividing x by 10 continuously. So we clip this down from 1, 2, 3, 3 starting here, so now we're down to 12. So we're looking at 12 now. So this next value, this modulus 10, is going to be 2. And since we have a 3 starting here, we don't want to add 2 to 3, because that would just be 5. We multiply the previous value reverse by 10, so now it's 30. And then we add this 2 onto there. So then we get 32, which is perfect. And then we'll take this off, and we do the same thing again. Reverse 320. Actually, now I'm thinking about this, we might have to do like a math.floor thing. So import math. I think that's how you do it. And then we'll go. Actually, we could do. I think this is math.floor also. Doing that double divided sign, I'm pretty sure it gives you the floor value of this. Because in Python, if you do it like this, it's going to give you the decimal value automatically. It's going to give you a double or a float, whatever that may be. It'll just automatically convert it, and that's not what we want. So we do that, and then yeah, so we'll do that continuously. But now comes the issue. So at the end we'll return reverse, right? But now we need to check to make sure it never goes over that 32-bit range, which is kind of a weird one to check, because as we've seen, I was thinking of doing something with like overflow. So if I did something like this instead, something we could do is to check to make sure it never reaches that overflow point, because it could very easily get there. You could do keep track of the previous one, right? So the previous value, I'll do previous reverse, and then we'll set it to this. So that way we can have a check. So this might be better if we do it down here. We can have a check if reverse. So essentially we'll do the opposite of this. So if reverse how would I do this? Reverse divided by reverse minus x modulus 10, and then we do this, and then divide this by 10. That should get us to the same value, right? So if we have 3, 2, 1, so this current value is going to subtract by x modulus 10 because we haven't divided by that yet. So then that'll be 320, and we divide by 10, it should give us 32. Okay. And if that doesn't equal to the previous reverse, I might have to convert this to an int actually. Or might have to do the math.for thing, I'm not sure. If that doesn't equal that, that means that overflow has occurred. I'm not sure if that's going to work though, since this is actually storing the values, which is not working with this. So this will be a good way to check for it automatically, and if that's the case, this will return 0. So the reason this works is because, like I told you, these are like represented by bits, right? So in the case that we go over the 32-bit range, so we get to 33rd bit, 34th bit, whatever, the value should change, right? So when we subtract, when we do the reverse operation of it, we're going to get an incorrect answer. So say we go 1 over the bit, right? Let me show you. So we get, so this should be, this is the max value we're supposed to be able to get, right? So it's, I'm not sure if you can even see that, to be honest. Can you? Oh yeah, you can. Cool. I'm not sure if I can highlight this. Let me see. Oh, you can. Okay, so this is the max value we can get, right? So say for instance, we go over it for whatever reason, right? So we get some weird number, and the actual value we're supposed to be getting is this plus 1. So when we do so max and then actual, so since we're going over the 32-bit range, it's not storing this properly. So when we do the reverse of it, so say 8 was the last value, which has to be the case actually. So 8 was the value. If we subtract by 8, we're not going to get the same value, right? Because we're going to get something weird. It's going to be like 1 off. So by checking that, we're checking for overflow, which I don't think this is actually going to work, to be honest. We can try, but it shouldn't work. Wait, what happened? Reference before assignment. Oh shoot. Okay, we initialize it up here too. So initially it should be just 0. Actually, that doesn't work. So we just auto initialize this to x modulus 10. Yeah, actually. That's the only way it'll work. We're getting tons of zeros, dang. 0, 0, 21. So one of them came out right. 2 of them actually. Oh, the negatives are coming out wrong. So if x is less than 0, we gotta add the negatives to the front. How would I do that? So rev that should be fine, right? Definitely not fine. That's weird. So the math.floor thing is working. We're getting some weird output. So 1, 2, 3, we're getting tons of zeros, and we get 121. So these 2 zeros, let's trace those. So 1, 2, 3, something's going wrong. So x modulus 10. So we go 1, 2, 3, right? So x modulus 10, this should be originally equal to 1, right? So when x doesn't equal 0, we haven't changed anything with x yet. I'm sorry, this should be 3. So reverse times 10, so it's going to be 0 times 10 plus x is 3. So this reverse minus x, which is going to be 0 divided by 10, 0. That doesn't equal 0. Then return that, blah. So theoretically it should be good as a matter of factual. I guess we can set a boolean if x is less than 0. So we'll initialize it to false. If x is less than 0, neg equals true. So then we'll test that neg. If that's true, then multiply by -1, which is fine. And then we could do absolute value of x, just to make sure we don't get any of those issues. So let's see if that fixes anything. I don't think it will. We got some deeper problems here. So we're getting 3, previous reverse equals reverse, which is going to be 3, right? So divided by 10, we should get 12. So we can test x right here, actually. We'll do an x string, and we'll check the divide of x. I can run that. I just want to see what it comes up with. 1210, that's perfect. Yeah, that's exactly what we want. Okay, so we'll continue tracing this. So we get 3, right? So now so previous is equal to 3's s 3 still. So then we'll do reverse again. So we're gonna get 32, right? So we're testing this. Minus x percent 10, which should be 2. So it's gonna give us 30 divided by 10. Well, I think it's gotta be like this then, right? Maybe that's the problem. Because it might be comparing a float to an int. It's not. Okay, so reverse minus x modulus 10 doesn't equal previous reverse. Okay, so we'll do that. Just gonna subtract by the 2. Just give us 30 divided by 10, which should give us a 3. If it doesn't equal that, it should return 0, which is not the case. So previous reverse is gonna be 32 by 10. So now x is write it up here. X equals 2. We're now at 1. Right. So we take the 1. X is going to be the 1. X modulus 10. Yeah. It's going to take the 1. Add it to this. So it's going to be 320 plus 1. 321. Which is perfect. So then we're going to get this. Be checking this. Yeah, kind of weird. This is not working. I don't know why this keeps returning 0. I like how I just run it again, thinking something different is gonna happen. So these first two are not working for some reason. 3, 2, 1. We could add some more test cases actually, see what's really going on. So the 120 works, which is weird. Oh, is it giving us a leading 0? Which is kind of not what we want. Oh, it doesn't give us a leading 0. The last one. So middle 2 after 21. After 21, we're getting another 0. Which is really... that's weird. Why is it doing that? Why change this to this? So anything that's over 2 is coming out incorrectly. Which is not... so this is going to be 3, 2, 1. Okay. So full trace. X is less than 0, negative. We got math.abs. Reverse equals 0. Previous reverse. X modulus 10. I mean, theoretically, this should work. I mean, unless we take this out. Do it like this, do it like that, and then if we do it similar to the way we did it before. I can check my submissions real quick. The accepted one. Well, I could do this range right here. Instead, this feels kind of cheap, honestly, because we're still storing the value. So this will probably work. Yeah, see. Submit. Yeah, see, it does work. Oh, geez, the runtime is really slow. Why is it so slow? 5%. Look at how much it changes. There's like a huge variance in that. So something's definitely wrong with this. It keeps giving us 0 for some reason, which it shouldn't. So YouTube is kind of smart. I don't know if I could pause this, to be honest, but I guess I'll just finish here. I can't figure out the range. I'll leave a comment with the solution for what's going on here, because there's something wrong here. So I'll leave a solution, some sort of comment that shows you what you're supposed to do. But this is not this is not the way you want to do it. Since we're storing this, we're getting pretty close. So that just checks for overflow, but it's gonna give us like some value we don't want. I guess we could put this literally in here, because this is the range we're supposed to check for, right? Actually, it does work, actually, because this is the max range of what we check for, right? So it's theoretically putting that in there should work. So if it goes outside of that range, okay. Not really the way I wanted to do it, but it's gonna work. Since we're not really testing for negative numbers here, that should be fine, right? If we convert that to raw negative, yeah. We can actually take this out and make sure that works. Yep. Okay, cool. That wraps things up. These numbers are coming out really low. I'm not sure if it's just the variance or what it is, but that actually works out. This ended up being a little bit longer than I thought it was going to be, but you know, we got to the solution. The way I wanted to do it was to test for overflow, but this is accepting reverse value. We're actually storing the reverse value in a value larger than it's supposed to be, which is not good. See, like, this is still technically still wrong, because in this case, this value is being stored in something that it's not supposed to be. I guess we still have the previous reverse as well, so we can still test for that. Yeah, we can still test for that, but that's what we're gonna go with. Okay, so that'll wrap things up. Catch you guys in the next one. Kind of a little bit of ramble. It'll be interesting to rewatch this, but good luck, and let me know if you have any questions or solutions to this problem. Peace.